Quality assurance. Quality assurance ensures that procedures, processes, tools, and safeguards are in place to achieve the defined quality standards for the project. Quality assurance is a proactive process that puts measures in place to prevent the occurrence of defects and poor quality in a project. Quality audit is an essential method for project quality assurance. The purpose of quality audit is to identify ineffective and inefficient activities and processes during project implementation. Quality audit reviews how the project uses its internal processes to deliver project outputs. Quality audit reviews the skills, expertise, and knowledge of the people in charge of producing or delivering project outputs. In addition to quality audits, the Plan, Do, Check, Act (PDCA) model is another useful method for project quality assurance. PDCA is the acronym for Plan, Do, Check, and Act. First is Plan. It is about establishing objectives and plan detailed processes required to achieve the desired project quality standards. Do means implementing the processes required to achieve the desired quality standards. Check means monitoring and evaluating the implemented processes by monitoring the project progress and activities against the quality standards. Act means applying corrective actions whenever the project progress and activities deviate from the quality standards. Let's explain the PDCA model with the example of a bridge construction project. Constructing a bridge will require, among many things, the use of high-quality construction materials, such as stones, concrete, cast iron, bricks, etc. The project team should plan processes to procure high-quality materials required to achieve the defined quality standards for this project. Once the construction starts, the project team should implement the planned process of procuring high-quality construction materials. Next step is Check. Check should include investigations to evaluate whether materials procurement standards and processes have been followed or not. During the checking, if it is found that the quality of materials is not up to the mark, then the project team must act. Acting could mean a revision in the materials procurement process that is lacking quality standards. For quality assurance, in addition to PDCA model, the project can use data gathering and analysis approach. Data gathering and analysis involves collecting and analyzing project-related data to evaluate whether a project's current progress and activities meet the specified quality standards. The team will analyze data in order to identify patterns or trends. The analysis may reveal quality issues that need immediate action. There are a number of tools that can be used for project data analysis. Here, we will discuss selected tools, such as check sheets, fishbone diagrams, Pareto charts, and histograms. Let's start with check sheet. Check sheet is a structured form for collecting data in real time at the location where the data is generated. Check sheet can capture quantitative or qualitative data. When the information is quantitative, the check sheet is sometimes called a tally sheet. The figure here shows a check sheet used to collect data on the reasons behind delayed arrival of construction materials at a construction project site. At the point of receiving the delivery, a team member recorded the delayed arrival time and different reasons behind their delayed arrival. The tick marks in the figure were added as data was collected over several weeks at the project location where the delivery truck offloaded the construction materials. Identifying and analyzing the causes behind delays will help the project team to take appropriate corrective measures and solve the issue. Now, we will discuss fishbone diagram, which is also known as the cause and effect diagram. Fishbone diagram is a popular tool to deeply investigate causes of a problem. An example of fishbone diagram is presented here. Main causes behind product defects found during the project implementation is being investigated here. The lines coming off of the horizontal line represent different contributing factors or causes behind the project defects, such as manpower, materials, machines, and environment. The project can now dig into each of this contributing factor to find a number of related sub-causes that are contributing to the product defects. For example, manpower is a contributing factor to the product defects. By analyzing the issues related to manpower, project team identified that demotivated staffs and unqualified workers are two sub-causes behind product defects. Now we are going to discuss histogram. Histogram is a bar graph that uses the height of the bar to convey the frequency of an event occurring. Each bar in a histogram corresponds to the frequency of occurrence of a specific event. The histogram presents two variables in two axes. For example, a company uses bricks as materials for its construction project. There are reports and incidents of many bricks being damaged. Project team uses histogram to present the reasons for damages on one axis and the corresponding number of damages caused by each reason on the other axis. The figure here shows that 200 bricks were damaged because of their poor quality. 400 bricks were damaged during the transfer from the warehouse to the site of construction. 1,400 bricks were damaged due to poor handling by the workers. Based on this information, the project team concludes that poor handling by the workers is the most critical reason for wastage of bricks. So, immediate attention must be given here to resolve the issue. Now we are going to discuss Pareto diagrams, which look similar to histograms. But there is a striking difference. In Pareto diagrams, the bars are presented from highest to lowest in order. Pareto diagrams are based on the rule of 80-20 rule. According to the 80-20 rule, a small number of causes, 20%, create the majority of the problems, 80%. The project team identifies those small numbers of the causes and gives more attention and resources to avoid them. As a result, the team will be able to solve the majority of the problems. The illustration here presents different errors causing the delay of a software project by an IT company. Based on the summarized data, the company concludes that coding errors contribute more than 80% of the reasons behind project delay. So, the project team will give more attention to reducing coding errors so that the project delay incidences can be reduced significantly. We have now covered 4 popular tools for project data analysis, which can be used for project data analysis as part of quality assurance process. However, quality assurance is not about one-off improvement based on project data analysis. Quality assurance is a proactive process. Project teams should have the willingness to embed continuous improvement. Continuous improvement involves continuously looking for ways to improve the quality of activities, processes, and progress of a project. Kaizen is a general term that was first popular in Japan to emphasize the importance of regular, minor, yet incremental improvements. Kaizen means to alter, kai, and make better or improve, zen. Many project teams have embraced the Kaizen philosophy as part of their quality assurance efforts. Similarly, the philosophy of Total Quality Management (TQM) encourages many project teams to focus on finding ways to continuously improve at every level and every aspect of the project implementation. TQM focuses on deploying the best practices, policies, and procedures in order to ensure high-quality project outputs. Moreover, TQM focuses on training project team members to meet the standards required for achieving the defined quality. TQM and other continuous improvement tools, quality audits, PDCA model, and data analysis methods that we have discussed in this video are all important for project quality assurance.